Hello everyone, welcome to this video. Today I will walk you through a Python project that detects whether an image is AI generated or human made using a deep learning model. Let's get started. First, we import the necessary libraries like OS, Pandas, NumPy, Matplotlib, TensorFlow. Next, we define the dataset and the model configurations like data path, the folder where the train and test images are stored, the train and test CSV files that contains image file names and labels, image size of 128 into 128 pixels before feeding into the model, batch size, number of images processed in one step, epoch, number of times the model will go through the dataset during the training, and the model file, the file where we save the trained model. Now we load the dataset from the CSV files and process the file paths. We read the CSV files using pandas.readCSV. Now, the file name column is updated to include the correct file path. We remove the missing data and filter only the valid image paths. And we convert the labels to human and AI for training, 0 for human and 1 for AI. Next, we use the image data generator to prepare our images for training. We rescale pixel values from 0 to 255 to a range of 0 to 1. We apply data augmentation to help the model learn better. We split the training data 90% for training and 10% for validation. We create the training and validation data loaders. Flow from data frame reads images from the dataset and prepares them in batches. The training generator is responsible for training images. The validation generator helps in evaluating model accuracy during training. Now we define a deep learning model using sequential. A 2D convolution layer extracts image features. Batch normalization speeds up the training and improves accuracy. 2D max pooling reduces image size to extract important details. Flatten convert the 2D feature map into a single array. Dense adds a fully connected layer. Dropout 0.5 prevents overfitting by randomly turning off some neutrons. And final layer sigmoid activation outputs 0 or 1. And now we compile and train the model. We use Adam Optimizer for efficient learning. We use binary cross entropy loss because we are solving a two-class problem. The model is trained for the defined number of epochs. Once training is done, we save our trained model for future use. The model is saved in .h5 format so we can reload it later. Now let's visualize the training result. We plot the accuracy over epochs to check how well the model learned. We plot the loss over epoch to see if the model is improving or overfitting. Next, we load the test dataset for prediction. We process the test image paths just like in training. We prepare the test images using image data generator. Now we use the trained model to predict whether an image is AI generated or human made. We use model.predict to get probabilities. If the probability is greater than 0.5, we classify it as AI generated, otherwise it is human generated. And we save the predictions in test_prediction.csv. And finally, we define a function that makes a prediction on a single image. The function loads an image and resizes it to 128 into 128 pixels, converts the image into an array and normalizes it, feeds it into the trained model to get the prediction, and it prints the result whether an image is AI generated or human made. And that's it. We have successfully built a deep learning model to detect AI generated images. This can be used in security, media verification, and many other fields. Hope you enjoyed this video. Do not forget to like, share, and subscribe to my YouTube channel. Thank you.